Hello, everyone. This is the Experiment 3 or Lab 3 Mass of a Black Hole by Kiana White. The goals of this experiment were to determine the mass of the black hole, calculate the net force acting on the star, analyze the momentum with respect to FNet perp and FNet parallel. The principles used in this experiment or this lab were the momentum principles, the FNet parallel principle, the FNet perp principle, and the universal gravitational principle. And the formulas for those are as followed. Here's one for momentum, for FNet parallel, for FNet perp, and then for FGrav. The results were in GlowScript, which will be shown here shortly. And here is the seed for the first part of the experiment. Now looking at the first experiment, we have the gravity constant at the top, and just defining some stuff here, the delta T, star, defining the while loops, the positions, just simplifying. And at the very bottom, we have the start of the loop, which we fill in the V initial and V final. We then continue to fill in with the P initial and P final, which is the mass of the star times velocity initial. And for P final, mass of the star times V initial. We then calculate delta T. We then calculate dP dt. We also use FNet, which is the P dt P hat. We have the mag of dP dt. Then we have dP dt parallel. We have FNet parallel. We have the dP dt perp, FNet perp. We then calculate the mass of the black hole, which is the formula shown with the FNet mag. We then also update the position and the velocity. And then the next step is just drawing the arrows. And then it continues. Here are the arrows all the way. And now let's look at the video for that one. So let's run this program. And again, we know that the n hat points in the direction of the center, p hat points in the motion, and then the FNet points between those two. And that is calculated. Now, moving on to part 2. Again, just defining some key concepts here. We use 8,000 or 86,400 for the minutes in the day, I believe. Or I'm sorry. Yes, minutes in the day. We then continue with the planet speed, just the constant stuff. Then you edit the lines for the initial conditions, which are the speed, but it cannot move faster than light, so make sure you calculate those accordingly. We then fill in the rate. We then go through and edit the net forces from FGrav on the planet by the black hole, FGrav on the planet by the spaceship, to the net force on the planet, which is just both of those calculated and added together, which you can see there. FNet on planet is equal to the FGrav on planet plus on the ship on planet. Then you do the net force of the spaceship, which is the same thing. The only difference is instead of using the values for the planet, you use the values for the ship, which can be seen here accordingly. And then we use Newton's second law to update the position, which you can see at the bottom. And then continuing down, we make the object move. And yes, and then we run this one. And yes. So I don't know why my arrows aren't showing, but I think they're there. They just might be too small. Yeah, they're here. They are there, if you can see them. They're just also really small. So yeah, the way I'm moving is how it goes. But anyway, the ship moved away from the black hole successfully without crashing into it. Thank you.